This is Athena, the goddess of mathematics, who happens to be the proud owner of a special pair of parallelogram-shaped sandals, which imbue her with flight and allow her to travel swiftly across all terrains. Recently, Cleon, an honest and geometrically blessed cobbler, has learned that Athena wants to pass on her magical footwear to someone equally bright. Should Cleon get the winged sandals, he wishes to use his cobbling skills to bring the power of flight to all his customers. Winning over Athena, however, is no mean challenge, and the access to her prized possession will be decided over her favorite geometric puzzle, one that involves a giant marble hiding away the sandals. Traditionally, the parallelogram-shaped sandals were always kept safe underneath a parallelogram-shaped marble. The rightful heir to the winged sandals, therefore, would be the one who can determine whether the marble placed in front of him is a perfect parallelogram or not. The catch is, Cleon cannot choose to touch the marble or physically measure any of its sides. The only clue Athena has for him is that each pair of opposite angles of the quadrilateral are equal to each other. Mathematically speaking, if A, B, C, and D represent the four vertices of the quadrilateral such that angle ABC is equal to angle ADC, and angle DAB is equal to angle DCB, can Cleon determine whether ABCD forms a parallelogram? If so, prove how. In previous lessons, we've learned that for a quadrilateral to be called a parallelogram, each pair of its opposite sides must be parallel. Mathematically speaking, line segment AB should be proved parallel to CD, and line segment AD should be proved parallel to BC. The question is, how can we do that? Well, for starters, AD and BC can be thought of as two lines being cut by a transversal. This gives us a pair of co-interior angles denoted by DAB and ABC. Similarly, AB and CD can also be imagined as two lines being cut by a transversal called AD, which results in the formation of co-interior angles denoted by DAB and ADC. If only we could prove these pairs of co-interior angles to be supplementary, AD would become parallel to BC, and AB would become parallel to CD. But before we can do this, we must find a way to quantify the sum of these angle pairs. A simple way to do this is to invoke the angle sum property of a quadrilateral, which states that the sum of all internal angles of a quadrilateral is equal to 360 degrees. Mathematically speaking, this means that angle DAB plus angle ABC plus angle DCB plus angle ADC is equal to 360 degrees. Given that angle DAB is equal to angle DCB and angle ABC is equal to angle ADC, we can rewrite this equation as twice of angle DAB plus twice of angle ABC being equal to 360 degrees. On dividing both sides by 2, we find that the sum of angles DAB and ABC is equal to 180 degrees. In fact, that's pretty much the end of the proof. You can just swap angle ABC with ADC to prove that the sum of angles DAB and ADC is also equal to 180 degrees. As promised, the supplementary nature of angles DAB and ABC means that lines AD and BC cut by transversal AB are parallel to each other. Likewise, the supplementary nature of angles DAB and ADC means that lines AB and CD cut by transversal AD are also parallel to each other. All in all, ABCD is a parallelogram, and one can conclude that whenever both pairs of opposite angles of a quadrilateral are equal, then the quadrilateral can be called a parallelogram straight away. Having proved ABCD as a parallelogram, Cleon sees the marble slab shift aside, revealing Athena's winged sandals. While Athena is happy to have found a new home for her sandals, Cleon can't help but zip through the skies, imagining a brighter future for all his customers.